Now there are lots of Spring Boot videos, so why did I create another one? When I wanted to learn Spring Boot, I found out that these smaller videos didn't have much information, and when I went to Udemy, the Spring Boot videos were like 20-30 hours long. And if you have ever used videos to learn, you know that a 1 hour video usually takes us one full day. It's very difficult to hold our attention. I wanted to learn Spring Boot. At the same time, I want a video that is like around 3 hours long. So I went about creating one. We're going to create a simple Spring Boot application, a RESTful web service with the React UI. If you look at any modern enterprise application, this is the architecture that they usually follow. These are the topics we're going to cover. We will do the setup. We will create RESTful web services. We will integrate Lombok, connect to the Postgres database using the Spring Boot Data JPA, create a one-to-many association between a student and task table, create a many-to-many relationship, incorporate the Spring Boot activator, logging, validation, global exception handling. We will test using Mockito. We will integrate Swagger, and we'll create a simple React UI so that you will know how these UIs will be able to call those web services. This course is going to be around 3 hours long. It's going to be simple, to the point, and fast. Hope you will enjoy it. Let's start with the installation and setup. We are going to install these tools. If you have already installed these tools, you can move on to the next chapter. So we are going to install the Zulu JDK, Intellig Community Edition, Json Viewer, Postman, and the Postgres database. All of these are open source, so we don't have to worry about any licensing or cost. Let's start with Zulu JDK. Let's search for Zulu JDK download. Let's select this downloads link. Depending on your OS, I'm going to download the zip file and unzip it. I have the zip file. I'm going to unzip this file. In my C drive, I have created a dev folder, and I'm going to unzip it right here. So we now have the Zulu JDK. Make note of the bin folder, copy this, and we need to edit the environment variable. Type env over here, edit the environment variable for your account, and over here, select path, click edit, add a new path, and put the path of the bin folder in our Zulu JDK. Now click on OK. Next, go back to this Zulu JDK, copy this path. Once again, in the environment variables, we need to create the Java home. You can either do it for the system variables or you can create one for the environment variable. So create a new variable called Java_home and put the path. Remember, it's not to the bin, it's just to the Zulu JDK. And click on OK. So we have set up the Java home as well as the path. Now that we have installed the JDK, let's install the Intellig Community Edition. Let's search for Intellig Community Edition. Go to Downloads. You may need to scroll down to the Community Edition, and over here, let's click on Download. Let's run the installation file. I'm going to leave everything in the default location. Click Next. I'm not going to select anything over here. Let's click on Next. Click on Install. This will take a while. Let's click on Finish. Next, let's install the Json Viewer. Search for Json Viewer. Go to the Chrome Web Store to install it. And click on Add to Chrome. Next, let us install Postman. Search for Postman download. And let's download the Windows 64-bit app. Let's install Postman. So we now have Postman installed. You can, if you want, sign in or create an account. I'm just going to use the light version. Next, let us install Maven. Let's search for Maven download. Go to this URL and let's download the zip file. Let's unzip this. You can unzip it anywhere. Let's click on extract. Now we need to set the path for Maven. So let's open the unzipped folder. Copy this wherever Maven was installed. Go to the environment variable again. Click on new. Set Maven underscore home to wherever you installed Maven. Click OK. Create another one and here set m2 underscore home to the same path. Maven underscore home is for the Maven 1 version and m2 is like Maven 2 and above. Click OK. Now select edit over here in the path. Click on edit. Click new. And over here, you can once again set this path along with the bin directory. So let's do this Apache Maven /bin for the path and let's click on OK. Click OK. Finally, let's install the Postgres database. Next, let us download the Postgres database. To install Postgres, search for Postgres download. Let's go to the downloads. And over here, you can select your OS. And in this page, you see the small link over here in the top corner. Click on this, download the installer. Now this is one way to install the Postgres database. The second way to install the Postgres database is downloading the binary and unzipping it. I'm going to do it the second way, but either way is just fine. To download the binary file, go to the URL shown here. And here I'm going to select the Windows version. I'm creating a new folder called DB in my dev directory. And I downloaded the Postgres binary zip file in the dev DB folder. Now open up command prompt by going to Windows CMD. Right click on the command prompt and run as administrator. Go to the directory where you have the binaries. And in this place, enter this command. The command you should enter over here is *-xf and the binary zip file name. Now press enter. This will unzip the zip file. Once unzipped, you will see this folder PGSQL over here. Go to the bin folder, copy this path, and we need to add this path to our environment variable. Go to env, edit the environment variables of your account, path, edit, new, and add this path right here. Click on OK and click on OK. To verify if Postgres has been installed successfully, let's close this, open the command prompt again. And in the command prompt, type in Postgres -v. And you can see that Postgres 16.3 has been installed. Now that we have verified that we have the database server installed, let us now create a database in the database server. To do that, enter this command, initdb -d the location of the database /data -u for the user ID, Postgres, and this is the encoding. Press enter. So you can see that the database has been created. So this confirms the database has been set up. Now to start the database, run this command right here. They would give this command. Take a note of this command. Copy this, paste it right here and start it, and also save this command and then click enter to start the database. So here you can see that the database server has been started. Now open Notepad. In the first line, type in echo off and paste the start command right here and save this file as a .bat file in your desktop. So here you can see that I am saving it as a start_postgres.bat file, so that going forward, if you want to start the Postgres database, you just have to double click on this file. Let's click save. So this is the command to start the database, and you can run the same command with stop over here to stop the database. So now that the database has been started, let's go and take a look at the database. The database admin is located in this folder in PGSQL. Select pgadmin4, double click on runtime, and here you can see the pgadmin4 exe. This is the UI for our Postgres database. Make sure to select the pgadmin4, right click, and pin to taskbar, so that at any given point of time you can just come here and select this database right here. So let's click and start this. So now that we have the pgadmin4 tool open, go to servers, right click on the servers and click on register server. Over here you can give any name to the server. I'm going to give the name as my Postgres. Next, click on connections and give the host name as localhost. And make note of the port number. The default port number is 5432 and we're going to keep it as it is. 5432, very easy to remember. The username, let it be Postgres, and for the password, I'm going to give the same as the username so that it's easier to remember. So my password is going to be Postgres. Easy for me to remember. I'm going to say save password so that I don't have to enter the password every time I start this. It is local to my computer, so I'm fine with the security part of this. And now let's click on save. So we now have a Postgres server created. And by default, there seems to be a Postgres database. If you want to run queries on this database, you can just select this database right here and click on this query tool. And here you can write your queries. You can see that it is connected to the Postgres database right here. And the tables will be over here. So this completes the installation of the Postgres database. Now that we have installed all these tools, let's go to start.spring.io to create our Spring Boot Initializer project. In this website, start.spring.io, let us select the project type Maven, language Java, Spring Boot 3.3 or later version. Group is your company name. I'm going to say com.patrickvideos. Spring Boot Patrick Videos is the name of my project. Learn Spring Boot is the description. And here we have the package name. The packaging is jar and the Java version we have installed is 22. So after this, let us add some dependencies. So click on add dependencies. And here let us select Spring Boot Dev Tools. and Spring Web. For now, let us just add these two dependencies, and later on we will add other dependencies as and when we need them. So once you have done this, click on Generate. When you click on Generate, it will download a zip file. Let us just unzip this file to the dev projects folder. So I'm going to unzip this Spring Boot Patrick video zip file to the dev project folder. Now that we have unzipped it, let's go open this project in Intellig. Open Intellig. Let's click on Open. And in Dev Projects, I'm going to select this project, Spring Boot Patrick Videos, and click on OK. Trust the project. And here you can see our project, Spring Boot Patrick Videos. Now that we have created our Initializer project in Spring, let us take a look at the folder structure. So here you can see that we have the source folder with the main, and it seems to be having a package with one Java class. This is the starting class. Now you can see that it's complaining that the project JDK is not defined and so on. We can go fix it. To fix these issues, let me go here, click on the project, click on the file menu, and over here, let's click on settings. And in this place, let's search for compiler. And here, let us click build projects automatically. Now by selecting build projects automatically, whenever we save a Java file, it will automatically build. Let's click on apply. And now let's click on OK. Next, let's set up the SDK. And you can see that it has detected the 22 Zulu. We can select this. And you'll see the errors go away. You can also select the SDK anytime by clicking on this menu. Click on project structure. And over here in project, you can select the SDK Zulu 22. Let's click on OK. So we have now set up the Spring Boot project. Now that we have resolved the errors, let's look at the annotation Spring Boot application. This annotation indicates this is the main entry point, and it also enables component scanning. That means it looks for other components, configurations, and services in the subpackages. This annotation Spring Boot application denotes the entry point of our application. Going further, you can see that under resources, we have application.properties. We will have our unit tests right here. And this is our POM file. We will add to the POM file as and when we want to add more packages to our Spring Boot application. By adding to the POM file, we will be downloading the required packages from Maven. And you can already see that because of our starter project dependencies, it has already downloaded a lot of packages for our project. You can see them in the external libraries. It has downloaded so many packages because of our dependencies. We can also look at the dependencies by going to the users, your username, M2 folder repository, and here you can see that in the org, Spring Framework, all these dependencies have been downloaded. If you don't see these packages, that means Maven has not downloaded the dependencies. Now that we have set up our Spring Boot project, let us go create our controller. Now in Spring Boot, all requests from the UI first goes to the REST controller. So in our project, let us first go create a REST controller. So let's go to this package, right click on the package, new package, and let's create a controller package. So we now have a package called controllers, and under controllers, let's create a Java class. A Java class called LearnController. Controllers usually have the name controller in it. So it can be any controller in this case. So I have a class called LearnController. I want to change the background from black to white. So I'm going into File Settings and Appearance and Behavior. In Appearance, let me do the light theme. This is much better for creating videos. And here, let's go to Editor General. We can also change the font size by using the Control and mouse wheel. And let's click on Apply and OK. So this way, when I keep the Control key pressed and the mouse wheel, it kind of becomes bigger. Now to denote this Learn controller as a REST controller, all we have to do is put the annotation REST controller on top of it. By marking this controller as a REST controller, we are now enabling this controller to receive or handle HTTP requests. Now in this controller, let's create a method. Now in this Learn controller, I have a method called hello, which returns hello world, a string. Now for this method to handle HTTP GET requests, we need to put the annotation at GetMapping. So now that we have this annotation at GetMapping on this method, let's go run this project. To start the application, let's go to the Spring Boot Patrick Videos application. And over here, we can either right click and say like run Spring Boot, or you can go over here, click on Edit Configurations, add new run configuration, select Application, and in this we can give something like Start Project and specify the main class as Spring Boot Application and click on OK. So this way, whenever we click on this play button, it will run this file. And let's click on Apply and click on OK. So let's click on Play button over here. Allow access. Now you can see that the project has been initialized at Tomcat 8080. So let's open up Chrome, and in Chrome go to localhost 8080. And you can see that the hello world has appeared over here. See this? All we did is create the controller, put the annotation REST controller so that it can handle requests. And then we created a method called hello, which returned the word hello world. And we marked it with an annotation called GetMapping. That means it will handle GET requests. And in Chrome, we simply called localhost 8080. However, if we feel like, hey, what happens if I have another method? And let's call this as world. Now, how do I call this method? The problem is we now have two methods with GetMapping and nothing to differentiate them. So this is where a URL comes in. So we can specify unique URLs to these GetMappings. Something like this. Within parentheses, we can say, when I call hello, return this. And over here, when we call world, return this. To differentiate these two, let's put this as world hello. So when we say /hello, it will return hello world. And when we say /world, it will return world hello. Let's run this application right now. See this? Now let's go back to Chrome. Now the localhost 8080 will no longer work because we don't really have a mapping for this. But when we say /hello, you can see that we have hello world. and slash world, we now have world hello. So this is how mapping works. Now let's add some more to this. Let's rewrite this method something like this. So here you can see that this hello now has a parameter called string name. Go to advanced settings. Click on this allow automake to start even if developed application is currently running. And let's click on apply and OK. So in this new method, we have a parameter called string name, and the return is going to be a formatted string with hello and whatever name we pass in. We have now introduced another annotation called request param. Let's import this class. So the request param is coming from this package, and the request param has a default value of world. So if you give a name, it will use that name, otherwise it will use the default value of world. The value parameter is the name that you're going to use in the URL. Like for example, sometimes in the URL, we want to give a different name for the parameter, whereas the actual parameter name may be different. Let's say over here we have username. It's going to return the username. But while calling the URL, we are going to give the parameter name as name. Now to call this method, we can go to localhost hello, and we don't actually have to give a value. You can see that it returns hello world because the default value is world. It will return hello world. But if we want to give some value for this username, we will use the parameter name as name. Something like this, question mark name is equal to John. Press enter and we have got hello John right here. You can see that we are not actually giving the parameter name. We are not giving username, but we are giving the value name. So here you can see that the UI, in this case, the Chrome browser, sends a request. It goes to the REST controller and then it receives a response. So this is the basics of how the controller handles requests. Now that we have seen the basics of REST controller and GetMapping, we can also have a base path. So what do we mean by base path? So you can see that in the URL, we're giving the GetMapping path right here. Imagine I want something like /API/hello. I want this to work. So for that, I need to have a base path called API for all the methods in this controller. So here, on top of the learn controller, I can say something like request mapping, and we can give the base path as /API. Save it. So now, if you're calling any of these methods, you can use something like 8080/API/hello for this method and /API/world for this method. So you can see that this will work right now. And for the other method, you can say /API/world. So this is the base path. Let's add a few more methods. I'm going to comment this out. I don't need the base path. So here you can see that we have another method called employee with the getMapping/employee. You can see that it has the request param, employee ID, and employee name. But the name of the parameter in the URL is going to be ID instead of employee ID. And for this one, it's going to be EMP name, since we don't really have a different name right here. Now you may wonder, for this request param you used value and for this request param you used name, what's the difference? Actually, they are interchangeable. You can use either value or name. Both of them mean the same. In the URL, you're going to use ID right here. This request param required is equal to false. That means this is optional. And you're returning a string where it says hello, your employee name, the second position right here, your ID is, and this one over here. So to call this method, we can either say /employee, and we can give both the ID and EMP name, or you can just give the ID because employee name is not required. So let's test it out. So here you can see, hello Alex, your ID is 100. And if I don't give the employee name, hello null, your ID is 100. Let's do one more method. So here we have a method called person, which takes in a parameter first name and another called last name. They both have default values and their value is L name and F name. And you're returning an object of person. So here you can see that the person over here is a record. Now, if you don't know about records, records are like a simple Java class that you can create on the fly. When you do something like this, record, person, first name, last name, behind the scene, it will create a simple class called person with private fields and constructor and getter methods, and it overrides the equal to and toString methods. So if you feel like I want a class on the fly quickly, you can use something called as record instead of creating a separate class. So this method person is going to return the person object. You can call this with /person with no values, and if you don't give any values, the default values will take over. And if you give some values like this, it will return the person object with these values. Let's test them out. So the first request, we haven't given any value. The first name is first name and last name is last name. And you can see that we are returning a JSON object. And because we installed the JSON viewer, we have a nice display right here. If you give the values, you can see that the first name and last name is displayed as Linda Berry. So we have now learned the basics of the REST controller. We have seen how you can create a base path. And then we have seen a bunch of GetMapping methods and the use of the request param annotations. Now, when you're writing code or you're copy pasting code from the material, you don't have to go and manually import. There is a setting which will do it automatically for you. You can click on File Settings, go to Editor, General, Auto Import, and select this right here. Add unambiguous imports on the fly. So if it doesn't recognize any of these syntaxes, it will auto import that package for you. This is very useful. So I strongly suggest you have this selected. Even though in this course, I would have manually sat and imported everything, but this is a setting that we usually suggest you have it turned on. Now that we have learned about controllers and GetMapping, let us now connect to a database. Make sure to have your database started and your pgadmin 4 opened. And over here, let us go create a new database. So I'm going to right click on databases, create database, and let's call this database as SchoolDB. School database. And I'm going to click on save. So now that we have created the SchoolDB, select the database and click on this query tool. So any query we run here will run against this database, and you can verify it right here. You see that we are connecting to the SchoolDB. Next, to specify how to connect to the database, go to your resources folder on the left-hand side, right-click on resources and create a new file, and let's call this file as application.yaml. It can either be YAML or YML, that's fine. Application.yaml. And in this application.yaml, copy paste this configuration. So here you can see that our Postgres database runs on this port called 5432. We saw this while installing Postgres previously. The user ID and password was Postgres. And here DDL auto is create. That means it will create the tables if it does not exist. And we are going to use the PostgreSQL dialect. Save this. Next, we are going to create something called as a domain folder. That is, we want to create a table, but we want to model the table out of this class. So to create a domain folder, right click on this package, create a new package, and let's call this as domain. And in this domain package, let's create a class called student. And in this class called student, we have these three properties: a long ID, a string student name, and a string student email. Now that we have these three properties, we need to generate the getters and setters and a constructor and all those things, right? There are two ways to do it. The first way would be to right click on student, click on generate, and then you can say generate the constructor, getters, setters, and so on. But actually, there is a better way to do it. We can use a package called Lombok to auto-generate these getters and setters and constructors. Let's take a look at that. In our pom.xml, under these dependencies, I'm going to add a few more dependencies. So here you can see that we have added new dependencies, that is project Lombok, and then we have added the Postgres dependency, and Jakarta.persistence, and Spring Boot Starter data JPA. So here you can see that we have added 4 new dependencies. Let's save this. Now to download these, let's go back to Maven over here. And under Lifecycle, let's right click on install and then click on run Maven build. Let me just stop this for now. Right click and run Maven build. So this has downloaded these new dependencies. Now sometimes I have noticed that even if you download the dependencies, it won't work over here in these class files. So if you have a situation like that, you can go to File, click on Invalidate Cache, and here you can select this Clear File System Cache and Local History, Invalidate and Restart. You can do this if you feel like the new packages haven't been picked up. So now that we have downloaded this Lombok, Postgres, Jakarta.persistence, and Spring Boot Starter Data JPA, let's go back to student. Let's go back to our student domain, and over here, right on top of the student class, we are going to paste all these annotations. And in front of this ID, we are going to have these annotations, the ID generated value, and so on. Now, what do these mean? Let's first import these. So here you can see that it's not able to pick up these dependencies. So what we need to do is go here, click on Invalidate Cache, Clear File System Cache and Local History, and invalidate and restart. Let's do that. We have a suggestion here, suggested plugin Lombok available. Let's go configure this. Let me install this Lombok plugin and click on OK. Now to make sure the Lombok plugin has been installed, go to File, Settings, and here select Plugins and make sure the Lombok has been installed. If you don't see the Lombok plugin installed, search for it and install this plugin. Let's go try and get these annotations resolved. So you can see this. These are the import statements for these annotations. And let's take a look at these annotations one by one. It's asking me to enable annotation processing. I'm going to enable it. If enable annotation processing doesn't pop up for you, you can also click on File, Settings. Under Build Execution Deployment, go to Annotation Processors and select Enable Annotation Processing and click on Apply and OK. So now that we have done this, let's take a look at each and every annotation and the use behind it. The first annotation is the entity annotation. In your Java project, you're going to have lots of classes, but only certain classes we want to create a table out of. So this entity annotation will specify what classes we want to create a table out of. So when we say at entity, that means we want to create a table out of this student class. So it will create a table called student with these columns called ID, student name, and student email. The next annotation is the data annotation from Lombok. When you specify the @data annotation on top of a class, it will behind the scene auto-generate all the getters and setter methods for this class, as well as it will override the equals method and toString method. So instead of you sitting and writing all the getters and setters, just make sure you go to POM, add a Lombok dependency, and use this @data so that it will auto-generate the getter and setter. Even though you cannot see it to the naked eye, behind the scenes, you will now have all the public getter and setter methods as well as the overrides of the equal and toString method. The builder annotation is used to build objects. Like for example, when we are testing, we may want to build an object, so we may use it then. The noargs constructor from Lombok is used to create a noarguments constructor. So you don't have to worry about creating a noarguments constructor. Similarly, just by putting this annotation called allargs constructor, it will create a constructor for student with all these arguments required. So instead of explicitly typing those, just use these annotations and it will create them for you behind the scene. The ID annotation here denotes this ID as the primary key. So our student table will have this ID as the primary key, and this generated value annotation will auto-generate the primary key so that you don't have to worry about generating new IDs. So we now have a domain class created. Next, we are going to create our own custom exception, just so that you learn how to create custom exceptions. So in the domain class, I'm going to right click and then click on new Java class. And we're going to have a class called student not found exception. Now let's look at this code of this custom exception. We have created a class called student not found exception, which extends runtime exception. Since it extends runtime exception, we don't have to explicitly handle it whenever we are using the student not found exception. And this class has a constructor that takes in an ID, and it is passing in the message to the superclass saying could not find student ID and ID. So that means it's passing in this message to the runtime exception. Now that we have created a simple custom exception, later on we will learn how to use these custom exceptions. Now that we have created the domain called student and the student not found custom exception, let's take a look at how does it fit in the overall picture. So remember this, we had the UI, in this case it's the Chrome browser, and we were able to call the REST controller using an HTTP request, and it returned the information. Returned information like this. Now we are building out the rest of the projects. We are now creating domain classes called student, custom exceptions, student not found exceptions. Next, we need to create this repo connection to the database. We have already created a student DB database, so this part is done. So what is remaining is we now need to create the repo which will connect to the database and the service and an implementation of the service. So the next step is we are going to do the repo, and then we will do the service and one of the implementation of service, in this case the Postgres implementation. Let's take a look at it. To create the repository to connect to the database, Let us go create a package here called repositories. Right click new package, repositories. So we now have a package called repositories, and in this, let us create a new class called student repository. Now to connect this repo to the database, all you need to do is student repository extends JPA repository. That's it, and have this annotation called repository. Now what happens here is this. When you say student repository extends JPA repository and you specify the name of the domain class and the data type of the primary key, the data type of our student primary key is long. So once you specify that and you specify this annotation called repository, behind the scene it will create a connection between the student repository and our Postgres database. The Postgres database properties are right here in application.yaml, so it will create a connection to this database. And not only that, just by saying that it extends JPA repository, by default, it will have so many CRUD methods written for you. What do we mean by that? It will automatically create all these methods for us. Find all, find by ID, delete by ID, save all, count. All these methods will be implemented for us just by specifying student repository extends JPA repository. So you can see how easy it is to program Spring Boot. Of course, later on we will learn how to write custom queries, but for now, all the basic queries are written for you. And finally, let's take care of the service layer. We are going to create a service interface and an implementation of the service interface, which will connect to our repo, which then will connect to our database and fetch the data. So here, to create a service layer, let's create another package. Let's call this package as services. And let's create a new interface called student service. So we now have an interface called student service. Make sure that we import this class called student from this domain. So we now have a student service interface with these three methods. One abstract method called all, which will return a list of students. A create method, which will take in an input of a student object and return a student object. And a find student method, which takes in an ID and returns a student object. Now let's go implement this interface. So right here in services, we're going to create a new Java class. Let's call it student service impl. Since this is the service layer, we need to put the annotation called at service. This student service impl implements student service interface. And in here, we are going to write this code. The student repository. And let's have another annotation called at required arguments constructor. Now by using this annotation, we don't need to write a constructor for this interface right here. We can just comment this one out. Let me just resolve all these errors. For transactional, take the transactional from org.springframework.transaction.annotation. The list is from java.util and student not found exception. Let's import it. Now let's take a look at this code. We created an interface called student service with 3 methods, one to return all the students, one to create a student, another to find a student. In the student service impl, if you take a look at this diagram, we are going to have one implementation to it. We are going to make use of the Postgres impl. Of course, we have named it as student service impl, implement student service. Here you can see that we now have an instance of the student repository right here. Now what is student repository? If you remember, our student repository extends JPA repository, which in turn connects to our Postgres database. And it has all those methods like find all, save, create, and so on. So our student service impl is going to make use of the student repository object, and then it's going to make use of the inbuilt methods in the student repository object to fetch all the student or to save the student or to find a student. So here let's take a look at the all method. The all method in turn calls the student repository dot find all. You know that the student repository, we haven't returned the find all method, but we don't have to do it. As we saw, just by extending JPA repository, it will have those methods written for you by Spring Boot. So it will call the find all method, which in turn will connect to the database and fetch all the students and return the list of students. Similarly, the create student will receive a student object, and it will take that input and pass it on to the save method in the student repository. And once you save it, the save method will return a student object, which we are going to return it back to the controller. And we are going to have a find student method which takes in an ID, and it's going to make use of the student repository's find by ID method. And if it returns a student, it will return it back to the controller. Else it will throw the exception, our custom exception called student not found exception. Because our custom exception throws a runtime exception, we don't really need to have a try catch statement right here. If you notice, there is also something called as a transactional annotation over here. What this annotation does is, when we are saving the student object, if something goes wrong, it will roll back the entire transaction. So if you're going to do any kind of update or insert statements, you have to make sure that they have the transactional annotation over there. So now we have the database, we have the repo, we have a service and one of the implementation of service, which in turn makes use of the repo methods. We have the domain, student domain and custom exception, which we are using in the service. You can see that our service impl makes use of the student domain and the custom exceptions. So the final thing that's left is we now need to create a new controller for the student, which will process all the requests and then call the services, appropriate services, which in turn will connect to the repo and then fetch the data and send it back to the controller, which we can display to the end user. So next, let us create the student controller. So let's create the student controller. So let's go to controllers, create a new Java class called student controller. And in this, let's add this code. So in the student controller, we are naming it first as a REST controller so that it can handle the HTTP requests. The student controller has access to the student service. You can see that the controller always communicates with the service. We have one student service, so we have the property student service over here. And you know that once we have a property in a particular class, it has to be set because the student controller is now dependent on this property. We are going to call methods in this particular property, in this interface. So we can either have a constructor here, like a student controller constructor, or you can use Lombok to specify required args constructor so that Lombok will write the constructor for you. So you don't need this particular piece of code. And since there is only one implementation of student service, that is the student service impl, it will auto wire itself to that student service simple. Of course, you may have a question like, what about if I have two implementations of the student service? How do I choose which implementation to use? We will see that later on. But since student service has only one implementation, it will auto wire itself. It will dependency inject from the container. It will say like, okay, use the student service impl. And this student controller has one method called all, which returns a list of students. Now, how does it return the list of students? It calls the services all method. That is the student service implementations all method. The student service implementation all method in turn calls the repositories find all method. The student repository, you can see that since it extends JPA repository, it comes with certain methods like find all, save, create, find by ID. It automatically comes with a few methods which will then get the information from the database. So the student service impl will contact the student repository find all method, and it will return the list of students from the repository, which will then be returned by the student controllers all method. So you can see the flow. From the UI, we are making a request to the controller. The controller will then make a request to the service. The service will then make a request to the repo, and then the repo will make a request to the database, fetch the data, send it back through the service to the controller and to the UI. Now let's run this whole thing and bring it all together. Let's see if it works. So the first thing you need to do is make sure your database is started. You can run the bat file, or you can give that command to start the database. Open up your pgadmin Postgres database, go to your database right here, and you can see that under schemas, tables, we don't really have any tables right now. So when we run this application, what's going to happen is this. It will take a look at this application.yaml file. It knows that in the application.yaml file, we have to connect to this database. So it will go and connect to this database called SchoolDB. It knows that we have the student domain with the entity annotation. So it will create a table called student with these three columns, and it will mark this ID as the primary key, and it will auto generate the values. So let's run this and let's see if the table is being created. So let's start the project. We can either go to the Spring Boot application right here, the main file, right click and run, or click on this over here to start the project. So if you have your database running, you will notice that in the log over here, we have the create table command. You can see that it is creating the table. Let's go verify if the table has been created. Over here, let's go refresh the database. I'm going to right click, click on refresh. And you can see that the student table has been created. Now let's go click on this database over here and open the query tool right here. You can see that it is connected to the SchoolDB Postgres, and let us select everything from the student table. Of course, there is nothing there in the student table. We can see that there is absolutely nothing in the student table. Now, if we open up Chrome and go to this URL, that is localhost 8080 all students, our student controllers GetMapping is all students. So we are going to go to localhost 8080 all students. And if you press enter, you can see that it kind of returns an empty array because there are no students. Now let's go manually insert two students in the database and see if we can get the answers right here. I'm going to insert these two students. So now that we have two students inserted, let's go back and call the same URL. we got the 2 students right here. Let's go debug and see the flow of the application. I'm going to go stop the application. So we know that the very first place the request goes to is the student controller, and it will go to the all method because that's mapped to the all students. It will go here. And from here, it will go to the student service. The student service is an interface, so it will go to the implementation of the interface because the required args constructor would have automatically wired it or injected it. So let's go here to the student service implementation, and it will go to the all method right here. And in the all method, from the all method, it will go to the student repositories find all method. Now, of course, you are not able to see the find all method over here because it's like an inbuilt method. It will fetch all the students and return it to us. So let's debug this and see how it works. So in the Spring Boot application file, let's right click and click on debug start project. Now, before I do this, let's go to the application.yaml file, and you see this create over here. If I leave it at create, it's going to drop the table and recreate it. And then I have to insert the data once again. Since I already have the table now, let's go comment this one out. Uncomment DDL auto none. So this way, it will keep the table and data as it is. So let's go back here and then right click and debug start project. And over here, I'm going to call this URL all students. So you can see that the very first place it goes to is the controller. It goes to the request goes to the controller. Now from the controller, if I click on step over right here, it will go to the service. From the controller, it's going to the service and implementation of the service basically. And from the service, it's going to go into the repo, which will then fetch from the database and send it back right here. Of course, we don't have a breakpoint in the repo. So this is going to go fetch all the students and return the list of students back to the controller, which will then return it back to us in the UI. So let's resume the program. And over here, you can see that both the students have appeared. Now, if for any reason it doesn't work, these are the things you need to go and check. First, make sure your database is up and running. Second, make sure that the database that you created right here, by right-clicking databases and creating the database, this name matches with the application.yaml's database name. It has to be exactly the same. Also, the username and password are correct. You did that while setting up the database. And that the port number is the default port that you installed Postgres in. Second, make sure that your student class has the entity annotation right here. Next, make sure that there are no errors in any of these files. If you see any kind of errors, it may be because your directory structure is wrong, or you haven't installed the Maven files. You have to right click on install right here and run Maven build. And also make sure that you click here, invalidate caches, and click on clear file system cache and local history. And then click on invalidate and restart.